So now I'm going to go over a problem to demonstrate how to use the 68, 95, 99.7 rule, as well as some of the Z-tables and Z-calculators, so you guys can see how a problem is done. Here we have some summary statistics from the National Health and Nutrition Education Survey, and this survey is performed by the Center for Disease Control. So this is actual summary statistics on the heights of men and women in the U.S. You can see that the average height for men is about 5'9", but some men are taller than that and some men are shorter than that, which is what the standard deviation captures, is that variation. And for women, the average height is 5'4", and there's variation for that, which is captured by the standard deviation as well. So using these summary statistics, we're going to ask questions about how unusual it is to see a man greater than 6 foot tall or a female greater than 6 foot tall. So let's start with an easy problem. What percent of men are taller than 6 foot 0.2 inches? The first thing that we need to do is convert this into the normal model. So we have to calculate a z-score for this 6 foot 0.2 inches tall person. And since this person is a man, we're going to focus only on the summary statistics for men. So the first thing that we need to do is convert our observation of a 6 foot 0.2 inches tall man. We have to convert that into inches. And so a man that is 6 foot 0.2 inches tall is 72.2 inches. And the reason why we need to do that is because our summary statistics are given to us only in inches. So for comparison, we need to be them to be in the same units. To create the z-score then, we're going to put our observation first and then subtract out the mean. So the mean for men is 69.3, and then divide that difference, so the whole difference divided by the standard deviation. So the z-score is 0.99, which this is very close to 1. So we're going to go ahead and assume that this observation we're looking at is 1 standard deviation above average. And so we can use our 68, 95, 99.7 rule. Remember, the 68 portion of that rule says 68% of people should fall within 1 standard deviation. And so we're looking at people of greater than 1 standard deviation, so taller than 1 standard deviation from the average. And so to capture that, we're going to take 100 minus 68. That's going to give us everything outside of 1 standard deviation. And then to capture just the upper tail, we're going to divide by 2. That gives us a percent of 16%. So 16% of men are taller than 6 feet 0.2 inches. So let's try a similar problem, but for the women. So now we're going to focus on the summary statistics of the women, these two numbers. And we're looking at specifically what percent of women are taller than 5 feet 9.6 inches tall. So again, we're going to convert that into just inches, so that's 69.6 inches, and compare that observation to the rest of the population. So the rest of the population has an average of 64.1 inches. That goes second. So remember, our observation always goes first. The mean goes second. And then we're going to divide that total difference by the standard deviation for the females, which is 2.75. Once we calculate that out, we're going to get a z-score of 2. So what that says is a person, a woman who is 5 foot 9.6 inches tall is 2 standard deviations above average. So she's really far above average. Using the 68, 95, 99.7 rule, we can see how unusual somebody of that height or greater is. So how unusual that person is. So to find that percentage of people, or of females, we can look at that upper tail. So 100 minus 95, so 95 is associated with 2 standard deviations. We can look at the upper and the lower tail outside of 2 standard deviations. Since we only want the upper tail, women greater than 5'9", we're going to divide by 2 just to get the upper tail, and that's going to give us 2.5% of women. So only 2.5% of women are taller than 69.6 inches. So now let's make the problems a little bit harder. There may be instances when the z-score that you calculate is no longer an integer, so it's no longer perfectly 1, 2, or 3. And that means you can't use the 68, 95, 99.7 rule. What you'll have to use instead in these instances is that z-table that I gave you before. It's also available in your book. You could use your calculator if you have a TI calculator, and this describes how you can use it. You could use Excel, or you can use some online calculator as well, which I provided a link to on ReggieNet as well, this one and a couple other ones. I'm going to show you how to use both the z-tables and go through a few problems using Excel as well. So if you want to use your calculator, it's up to you to practice learning how to use that correctly. So here's a slightly harder problem. What percent of men have heights that are less than 5'9"? So 5'9" is associated with 69 inches exactly. And to calculate the z-score, we're going to take that observation, subtract out our mean, and divide by the standard deviation, specifically only of the men. And that's going to give us a z-score of negative 0.1. And we're going to use that then to find the percent of men that are less than 5'9". So this is the formula that we're going to type into Excel. We're going to put in the equal sign, norm dist for normal distribution. The first number is going to be your z-score. The second number is always going to be 0. That represents the mean of the z-scores, which is we've standardized to 0. And we standardized the z-scores standard deviation to 1. So the third number will be 1. And the last number is always be 1 as well. So here I've pulled up an Excel spreadsheet that we can calculate then the percentile. So I'm going to hit equals norm dist to pull up the function, and then I'm going to go ahead and put my z-score in, the mean of the z-score, the standard deviation of our z-scores. So the standard deviation is always 1. And then the last number for the cumulative distribution function, we're just going to go ahead and put 1 for that last number. When I hit enter, it's going to give me a number between 0 and 1 because this looks at a fraction. If we want to get this in percents, we're going to have to times this number by 100. So I'm going to times that number by 100, and that's going to tell us that 46% of men have a height that's less than 5'9". So does 46% make sense? We're dealing with a negative z-score here, and what a negative z-score implies is that you're falling below average. So the average is 69.3%. You know that half of the observations are going to fall below. So looking at an observation that's less than the average implies you're going to have less than 50% of the population. Now let's do this same number, but for women. So we're going to look at what percent of women fall less than a height of 5'9". So we need to find the z-score for the females, and we're going to do that using the summary statistics of just the females. So again, our observation of 5'9" goes first. The average for the females goes second, and then once we have that difference, we can divide that difference by the standard deviation. That's going to give us a z-score of 1.78. So what this number represents is how unusual a woman that's 5'9" is. So a woman that's 5'9" is 1.78 standard deviations above average. What we're going to do then is use this number to find our percent of women less than 5'9". So the normal distribution can give us everything that's below that observation. So again, we're going to take this formula and plug it into Excel. So now we want to find the percentile for women, and our z-score was 1.78. So we're going to use that in our normal distribution. So we'll hit equals normal to call the function of the normal distribution. Our first number is the z-score. The second number is the mean of the z-scores, which is 0. The standard deviation of the z-scores is 1. And then we're going to put 1 as our last number. When we hit enter, we're going to get a number between 0 and 1. And when we times that by 100, we will get the percent of women. So 96% of women are less than a height of 5'9". The last thing I want to do then is show you how to use a z-table to also solve these sorts of problems. So I'm going to go through two more problems then using a z-table instead. So here we're given a question of what percent of men are greater than 6 feet tall. Again, to start, what we need to do is we need to calculate the z-score that's associated with men who are exactly 6 feet tall. So to be 6 feet tall, you're going to be exactly 72 inches tall. We're going to put the observation first, the men's average height second, and then divide by their standard deviation. That's going to give us a z-score of 0.92. So a man that's 6 feet tall is 0.92 above average for men. So now let's go to our z-table to find what percent of men fall above this z-score. So the tables actually give us everything that's below a z-score, so we'll have to subtract 100 from our answer. To start, the first page gives us only negative z-scores, so you can see that these are all negative. And the z-score that we're looking at is 0.92. So we'll start by going to the page with positive z-scores. And here, so we'll want to go to the z that's associated with 0.9. So we're looking at the row 0.9, and then we'll go to the column of 0.02 because that's our second decimal place. So the percentile that we're given is 82.12%. But the table gives us everything that's below average. So 82.12% is the percent of men that fall below a height of 6 feet. And we want every man that falls above that height. So we're going to subtract this from 100, and that's going to give us a percent of 17.88. That's the percent of men that fall above a height of 6 feet. So let's answer the same question, but for women. What percent of women are taller than 6 feet tall? So again, 6 feet tall is exactly 72 inches. That's our observation. It goes first. And now we're going to use the summary statistics for women. So 64.1 average goes second. And then we're going to divide by the women's standard deviation. That's going to give us a z-score of 2.87. So a woman that's 6 feet tall is 2.87 standard deviations above average. That's pretty far above average. But let's look at how unusual it is by looking at the z-table. So again, our z-score is positive, so we're going to be on the page with positive z-scores, and we're going to go down this first column until we find the z-score of 2.8. That's our row that we're going to look at, and then we're going to go over to the 0.07 column because that's our second decimal place. And that's going to give us a percent of 99.79%. But again, the tables give us everything that's below our z-score. And in this question, it's asking for everything above our z-score. So we're going to subtract 100 minus 99.79, and that's going to give us a percent of 0.21%. So 0.21% of women are taller than 6 feet tall. So if you see a woman that's greater than 6 feet tall, she's pretty above average and really pretty unique. So that's how you use the z-tables or Excel to find different percents of things. The next thing that we're going to do is look at problems where you're given the percents and you have to find the observations back from that. So it's called reversing the percentiles. And once you're given the percents, you can find z-scores from that and then recalculate and derive from that the observation that's associated with that z-score. That's what we'll do next time.